Hi, my name's Andy. One of the things we pride ourselves at Rancher Government Solutions is this idea of white glove service. It includes everything from professional services, TAMs, architectural overview, account overview, and workshops. That's one of the things we're going to be talking about today. Now, in order to kind of talk through the workshop, we should probably level set a little bit as to what are all the products that we offer and how they kind of all integrate and work together. I like to call this the stack, only because of how it all kind of fits together. And if you think about it kind of vertically, at the bottom, you've got hardware, whether it's AWS, Dell on-prem, HP on-prem, it doesn't matter. I've got framework laptop boards behind me. I've got a NUC in the closet. Doesn't matter. Okay. The first product from SUSE, from Rancher, is a product called Harvester. Harvester is our hyper-converged operating system. What it basically means is containers and VMs sitting side by side, sharing a lot less compute, and being able to be deployed to things like tactical edge, near edge, telco edge, things like that. And because it's Kubernetes under the hood, you can still interact it with the same kind of infrastructure as code model that we do with all the other things in Kubernetes. Really kind of powerful, and there's some interesting crossover between small device management, lifecycle management of the cluster, as well as container lifecycle management as well. So that is an open source tool. It is available today. You can play with it, download the ISO, and boot it on any hardware you want. Moving up the stack, we have operating systems. Now, our corporate daddy, SUSE, has a couple different operating systems out there they fully license and support. We, however, don't matter. In the Kubernetes field, doesn't really matter which operating system you use. So if you've got a mandate for Rocky, CentOS, RHEL, Ubuntu, Alma, SLES, whatever it is, we absolutely do support it. It is not that big of a deal. Okay. Moving up the stack, we have K3S. This is our Kubernetes layer. We have K3S and RKE2. K3S was kind of a fun little project by an engineer years ago, and it's now kind of grown into this kind of behemoth of lightweight Kubernetes. It's stripped out a lot of the cloud API drivers and has also switched out etcd, I think, for SQLite, really giving a lot of flexibility in like a 60 meg binary. RKE2 is our enterprise grade Kubernetes, fully stigged, FIPS 140-2, SE Linux support, all the bells and whistles you could possibly want. The nice thing is that when we get up to like the storage layer or the networking layer, the CNI is swappable, the CSI is swappable. And again, everything I'm talking about is 100% open source. You can use it today. No big deal. Okay. Talking about the CNI and CSI, let's talk about Longhorn. Longhorn is our stateful storage layer. Really easy to deploy, and you'll see this when we get into the workshop. Really easy to deploy. It uses the aggregate storage. It doesn't require any additional storage. Works great on 3 NUCs. Works great in 3 VMs. It'll just work. Another notable thing about Longhorn is it supports encryption at rest. What that basically means is that the volume, the image file, the VM file on the, whether it's Harvester or whatever node you're on, that file is actually encrypted with a key that sits in Kubernetes. So it adds an extra layer of security at like 0.0001 performance loss. It's really lightweight, really good. Okay. Again, open source, malleable. You don't want to use Longhorn, use EFS, EBS, use what's available, NetApp if you've got it, and to kind of build out a good storage strategy. Moving up the stack, we have our networking and service mesh. Let's do the networking side first. Networking, again, because our CNI is malleable, by default we use Canal, which is a combination of Flannel and Calico. On the service mesh side, we have taken some of the best in breed open source products out there, and we've merged it into our Rancher layer. What this basically means is that we fully support the installation of Istio. It is fully supported. It is SLA'd under our Rancher paid support. Okay, moving up the stack to Rancher. At a high level, it is our cluster lifecycle manager and our application lifecycle manager. And I'll get into a lot of that in a few minutes into the workshop itself. But it's a really powerful tool. Extending its capability, moving up the stack again, we're into the GitOps. Obviously, Rancher supports Helm. It also supports a CD tool called Fleet. Fleet gives you that GitOps infrastructure as code, really kind of easy button to deploy applications. We'll actually deploy that in the workshop. Moving up to monitoring and logging. Again, with that taking the best of breed open source, we've taken Grafana, Prometheus, and FluentD and added them in as our logging and monitoring stack. We're going to actually deploy that too. And again, that is SLA'd. And then last but not least, NeuVector NeuVector is our security tool. It is unique in the category for Kubernetes security and how it functions. And I'll go into that a little bit when we deploy NeuVector. Really unique, really powerful, great for security visibility, observability, as well as network. We can do packet tracing, things like that. Again, we'll get into it. What I'm going to do is I'm going to throw the email up now. If you've got any questions and you don't feel like watching the rest of the workshop, feel free to reach out to us either in the comments. You can email me directly, natsec@ranchergovernment.com. That goes to our team. Anything we can do to help, absolutely feel free to reach out. Okay, let's take a look at the actual workshop itself. So I'm going to put this URL in the show notes. We use a tool called HobbyFarm. HobbyFarm is an open source learning management, very malleable, very slick in terms of how it stores, how you interact with it, and how it stores the VMs. Very easy to use, and we're going to use AWS in the background. Okay. We don't really need anything out here, but I also, just as a side note, I do have the content here if you want to go look at it at a later date. Great. So let me go ahead and log into our user interface for HobbyFarm. And I've already pre-created my VMs. I'm going to go ahead and hit continue. And we can see that we have 4 VMs. We have Ubuntu Downstream, we have Ubuntu, we have Slez, and Rocky. Rocky we're going to use as our control plane node, but we're also going to use it as a pseudo workstation. Okay, and we're going to deploy, like I said, RKE2, fully stigged, Rancher, Longhorn, NeuVector, and maybe a few other apps. Kind of as a challenge, but we'll definitely get to those. Okay. The nice thing about the HobbyFarm and the user interface is that every box here you can click and it'll actually either execute the command or write the file. So first things first, we're doing a sudo. We're making some directories. We are then doing some kernel tuning. This came out of years of working at Docker and working on operating systems. There's some nice to haves there. I'm not going to go into any great specificity on some of these things just because of trying to keep this video relatively short. Getting into the config. This is for RKE2 itself. This is the stig minus me commenting out the CIS profile. The reason why I've done that is there's some other security considerations you have to do in deploying NeuVector and other tools. I want to make this simple, so the easiest thing to do is to just go ahead and disable that. And by the way, that did write the file. And what's interesting is we can also do get enforce, and you can see that SE Linux is running in enforcing mode. So yay, we're doing something secure. Okay, cool. Now, because of the stig does call out an audit policy for RK2, we're going to go ahead and write that file. The Red Hat Network Manager, the RHEL Network Manager, does interfere a little bit with Canal. So we just put this file in. It says go ahead and ignore all of the settings for Canal or Calico or Flannel, and that works really well. And then we're going to do a curl pipe bash, and this time we're going to specify version 1.26. There's this happy medium between cutting edge. I think 129 will be out soon. 128 will be out soon. One of them. And then waiting for enterprise support to kind of follow. 126 is kind of at that sweet spot right now. When we go deploy our downstream cluster, we'll use 127. But really anything 125, 6, and 7, they're pretty much all backpatched and good to go. There's obviously some differences between 24 and 25 with the pod security policies, but for the most part, the changes are not as innocuous. They're not as big as the PSPs. Okay, cool. We see it's running. The system's starting. This will take hopefully another 30 seconds, 15 seconds. Don't quote me on that. Whoop. And while that's running, what I'm going to do is I'm actually going to go to the next step. And we're going to go now play with the Ubuntu node. Same kind of thing. Sudo make a directory. We're going to do the kernel configs. We're going to apply the kernel settings. We're going to do the Rancher config. And then we're going to go back to Rocky. Yep, we're done there. So that's coming up. And then we're going to go ahead and do our curl pipe bash, install and call it an agent. Since Rocky's back up and running, there's one last thing we need to do is this kube config. And this is because, again, we're using this as a workstation. And you can see now we've already got 2 nodes. One's ready, one's not. Great. Now let's go ahead and go over to Slez. Same kind of thing. We're going to do the sudo, and notice it's on the Slez node. Kernel tuning apply, config, go. Okay, perfect. And we can do is go back to Rocky and do get node. and we should see in a relatively quick order, it will go ahead and see, there we go. We've already got our third node checked in, and we have the, we're waiting for it to go ready. Cool. So now we basically have a 3-node cluster. We can kind of move forward. So again, because this is a workstation, we need to install Helm. Helm is pretty much the industry standard for application management. So we'll go ahead and install Helm, do a curl pipe bash for that, clear that out. And the really interesting thing with Helm is you basically do a repo add and then an install. So we're going to do it twice. We're going to add 2 repos. One is for Rancher, one is for JetStack, but that's Cert Manager. We need Cert Manager to generate the certificates for basically those dynamic self-signed certs for Rancher. Obviously, we support third-party certificates out there. Absolutely no problem with that. If you have questions or anything, you can reach out. I've got blogs and stuff how to update that, and we're going to point you to the docs as well. Cool. While that's loading, that looks good. Slez looks good. Cool. We'll give that a sec. Cert Manager, and then clicking that. Sorry. Rancher now is deployed as Helm, so we can do kubectl get node. Everything's up and running. We can do a get pod-a, and we can see we've got a whole bunch of containers running. Cert Manager's running cattle system. That is the Rancher application itself, and that is starting. So here's kind of an inside secret. Don't tell anybody. Rancher is just an application, right? The nice thing about it is you can deploy it on a cluster. You can deploy it on a big cluster. You can deploy it on a small cluster. You can deploy it locally. You can deploy it remotely. It is just an application. So in terms of the underlying Kubernetes, it's just an application, right? And you would troubleshoot it just like you would anything else. Okay, so what we're going to do now is I think we should be, hopefully it'll actually be responding. There we go. It looks like it's responding. Whoop, unavailable. We got to wait for it to come up its last time. Come on, give me the health check. There we go, health check. Go back here, refresh, and there we go. So we can see Rancher itself is up and running. We have to put in the initial password, the bootstrap password, and that's going to be password. Capital PA22WRD. I'm going to show you Keep Me Honest. We're going to log in. I always uncheck the telemetry just because of where I've worked. And then obviously check the you allow. And great. Now we've got Rancher up and running. Now for me, I always put it in light mode just because of how it looks. I think it looks better, especially in video. Okay, give you a quick tour of what's here. We've got our clusters listed. We have continuous delivery, which is that's Fleet. That's our CD tool. We've got our cluster manager. We've got a virtualization management, so we can actually talk to Harvester and manage VMs dependently or independently. We can go to users and auth. We've got auth providers, so we absolutely support OIDC, SAML2, OpenLDAP, through the use of Keycloak or any other kind of IPAM, IDP, IDM. Yeah, IDM tool. Okay, let's go back to the workshop, and let's move on to Longhorn. Okay, so there's some nice to haves with Longhorn. There's some requirements around iSCSI and NFS, so I'm just going to go click those 3. That will take a minute to come up, and we'll give that a hot second. We can go back here. While that's loading, let me kind of talk about the 5 ways to deploy applications. Okay, the first one, I do not recommend this. This is from least fun to most fun. Least fun, import YAML. I do not recommend this. You definitely want a source of truth. You want to make sure everybody understands what's being deployed. This is not the way to do it. But in an emergency, great. Okay. Method number 2 is you can create a Cloud Shell. The nice thing about this is it actually has K9s installed if you're into that sort of thing. It does take a second. It's pulling a pod from the internet. Okay. When it does come up, it'll use your existing RBAC to connect in and talk to the cluster. Okay, it's taking its sweet time. Let's try it one more time. Disconnected. Well, it usually works. I'll show you that in a little bit. Give it the cluster time to settle down. Again, we are loading a bunch of things. The NFS utils are good. Let's go ahead and deploy Longhorn, and I'll go back to the application management. There we go. That's deployed, and we can take a look at it. One thing to note about Longhorn being a storage class is that it'll automatically create the storage class. And we can see here as it's deploying its containers the storage class by default. So if an application says, hey, I need storage, Longhorn will be like, I got you. This is default. I'll build the volume out for you. One of the things I like to add is encryption at rest. We talked about that. But I just create a specific storage class for that. In fact, we'll deploy an app later that uses it. It's kind of fun. Okay. And we'll give this one more look. Yeah, things are coming up. We might be at a point where we can actually bring the GUI up, and we can. Great. One of the cool things about this, though, is notice I didn't authenticate. I'm actually going through Rancher's proxy and proxying into the service Longhorn front end. So this gives me a great way to get to applications without having to create separate ingress and kind of manage who can talk to what very easily. We can see that we have our 3 nodes. Again, it uses the aggregate. You could see that we have 0 volumes deployed at this point. Okay. Now that that's deployed, let's go ahead and do NeuVector, because NeuVector will take a minute. And it's the same kind of thing. Helm apply, Helm repo add, Helm upgrade, Helm install. Okay, we'll let that go. And I'm going to go on to the next. Do I want to go to the next? No, I want to wait. Wait for that to come up. And we have to wait for the controller pod. So let me get back to the application install methods, right? So 1 was import YAML. Don't do it. 2 is kubectl shell. There's something going on there. That's funny. It usually pops right up. We'll look at that later. Okay. The third method is using the kube config. So this will download that config to your machine, and then you can run whatever's locally on it, talking to the cluster. Again, we're going through that same front door, that same RBAC, that same nice to have, right? It's really good to have from a security standpoint of view. So that's 3. Number 4, we have an app catalog. In fact, if we go, let me go ahead and just do this real quick. That's up and running. We have an app catalog. We'll come back to NeuVector. We have an app catalog. And what we can do, and there's a section where we're going to use it, but that app catalog will allow you to install a bunch of different apps. Okay. And method number 5 is going to be fleet. Okay. So that's that automation. That's that continuous delivery. Okay. Let's real quick. Let's give NeuVector time to come up and settle. I'm trying to do this as fast as possible. We're going to skip ahead and come back. I know we're doing that a little bit, but again, it's for trying to decrease the size of the video. Okay, so we're going to use a tool for GitOps called Git. This is just a local version control. If you're curious what it looks like, there's a link. It's awesome. It's great. Actually, it is really nice. We're going to do a Helm repo add, Helm upgrade I. We're going to wait for that to come up. While that's coming up, we're going to go ahead. Yeah, perfect. This looks good. We're going to connect in a NeuVector. There's our EULA. Yes, we accept, and this will automatically log me in. It's using our single sign-on, which is great. I'm going to go here. One of the things that we like doing is I'm going to go to Assets, Containers, and there's this auto scan function right here. I like turning it on. So it's going to automatically scan all the images in the cluster for vulnerabilities. This is kind of, I think this is a really, this is a non-starter for me. You absolutely have to do this. And again, it's about security observability. Okay, and this will feed a lot of information into the dashboard about what's vulnerable, how exposed are we, what are the events are we seeing, things like that. Okay, let's take a look at the NeuVector network activity. So we can start to see red dots. These red dots are actual CVEs in the image. And we can go ahead and right mouse click on it. We can, let me go into it because there's 3 pods there. We can actually go into the pod itself, right mouse click it. We can do a packet capture. We can get details about the pod. We can quarantine it. We can hide incoming traffic. If we go into the detail section, we can go look see what vulnerabilities there are in that pod. We can see a bunch of CVEs for Go, it looks like. Yep, looks like Go. And the CSI resizer. Okay, this is a great way to kind of get that immediate inspection as to what's going on where. Because when the next heart nosy bleedy thing comes out, the first question everyone's going to ask is, how exposed are we? This is a great way to kind of show that, that level of exposure. There we go. We can see Git coming up too. Perfect. Okay. One of the other cool things about NeuVector is how it has the ability to look at the data. So it has the ability to inspect HTTP traffic for the log4j exploit. What this means is that it can actively see it coming and drop the packets. So it buys you time to update those applications downstream until you get it sorted out. Until you get an opportunity to update it, this will buy you that time and protect you. The other cool thing about NeuVector is this has this concept of discover, monitor, and protect. Discover is I'm new here, I'm learning. Monitor is I'm new here, but I think I know what's supposed to be gone based on its behavior analysis. And then I'm going to alert. I'm going to say, that doesn't look right. And then protect is, I know what should go on. I'm not going to allow anything outside that. So it's really powerful. You can even separate it from services versus network. You can even time bound it, right? So you can say in an hour, go from discover to monitor, and in 2 hours, go from monitor protect. So that gives application teams time to deploy things. Really powerful that way. Okay. And let's go to assets, containers, and we can see some of the processes are already finishing. Their scans are done. And let's pick on one, core DNS. That's a fun one. And let's pick it vulnerability. So again, we've got our report. We can actually export our report as CSV and use that to make better decisions for applications and stuff later on downstream. Awesome. Okay, GitOps up and running. Doubling back to that, so we deployed it just like any other app. Again, Helm repo add, Helm deploy, Helm upgrade. What we're going to do is we're going to do something kind of cheeky. We're going to mirror that GitHub repo. That's going to be in the show notes. In there, I've actually got a YAML that we're going to use to update and deploy and play with. Okay, so what we can do now is we can actually log into the GUI, and there's a sign in the upper right. This one's a little different. It uses Git instead of admin. But again, it's going to use that capital PA22, WORD username and password. Now we're going to go to the Git workshop, and here we are. Okay. One of the cool things we're able to do is we need to change an IP and then, again, use that YAML with Fleet to deploy. So if you click on that next link, it'll take us right to the YAML. And we're going to change the XXXX IP address to that IP address. Now, if you want to be a 10x developer, you have to commit your changes with no comments whatsoever. I don't make the rules. That's how you be a 10x developer. Okay, so that's working. And now what we got to do is we've updated our YAML. We've deployed version control. Now we got to connect the two. We got to tell Rancher where version control is. And the way we do that is with a Git repo object. So let me go ahead and clear this. We're going to go ahead and write the file locally to root Git. And all it's doing is it's saying, hey, that's great, I wrote it a second time. It's going, hey, actually, let me make sure I might have messed that up. Root Git. Nope. Okay, good. I did curious if it double wrote. But we're going to say, hey, here's the version control, here's the repo, here's the directory, put it in this namespace, go. And that's effectively what we did. So we can go back to Rancher, we can go look at continuous delivery, we can go to Git repos, we can change it to local, and we can see that we've got 0.1 cluster, but we can see we've already got resources being deployed. Okay, and while that's uploading, while that's actually starting to pull down the necessary pods and create those object types underneath, we can go take a look at Longhorn. And we should be able to see now we have 3 volumes. Okay, we've got one for NeuVector, we've got one for Git, and we've got one for Flask, Redis. But notice we have the lock. Okay, that was that storage class we created, and then that YAML contains the secret for it. So while we're waiting for that to come up, I can show you. This is just if you look in this directory, it's just a flat YAML that has the IP, that has the deployment, and has all the Kubernetes objects, including the secret, and that's the secret that's used to encrypt the volume on the hosts. Okay, so that's really cool. And we'll wait for this to come up. It's still thinking about it. Come on, buddy. Let's go back to Rancher itself. We can do clear, kubectl, get pod. That looks good. We can do -n. Oh, actually, got to put the Flask in there. That's the namespace. Cool. So it's fully up and running. We go back to Rancher. Sometimes the GUI gets a little chinky. There we go. It's just caching. Because I've run this demo a few times today and yesterday. So the nice thing is we're all up and running. So the cool part is, though, we can go in here and look. And notice we have 3 pods running. And we can validate that here. We have 3 pods running. But let's just say we've got an interesting event and we want to scale. So let's go ahead and scale that from 3 replicas to, say, 8. And again, got to be a 10x developer. You can't put any commit changes in. Can't put any description in. And the cool part about it is all we did was update version control, which is Git running on our cluster. Just updated it. Fleet is automatically pulling it. Roughly about 30, 45 seconds, it pulls it. Anything new, anything new, anything new. And then what will happen is once it sees the change, it'll go, oh, I got to make the change. And that's what it just did. It just automatically scaled me. This is fantastic. It increases developers' velocity. You eliminate the what should it be. You eliminate, especially the 3 a.m. PagerDuty calls. It's really kind of embracing that infrastructure as code ethos, okay? So that's fantastic. Let's go back to the workshop. If we want, we go to the app and boom, there it is. Notice now when we start clicking through it, we have a whole bunch of different nodes that are responding for our world's greatest Flask Redis demo, okay? So that was the 5th way we deployed applications, right? Through Fleet, through the infrastructure as code ethos. Okay, great. We've showed the 5 application lifecycle management ways. Now let's talk about clusters. So we have a downstream cluster, Z downstream. All I'm going to do is I'm just going to sudo, and now I'm root on that node. What we're going to do, this is kind of a choose your own adventure. This is hopefully you've seen a little bit, but I'm going to walk you through it because, YouTube. What we're going to do is we need to go into Rancher cluster management and create a custom downstream. So I'm going to go to the cluster management, and I'm going to click create in the upper right, and I'm going to go custom. I could do AWS if I had credentials, DigitalOcean, Harvester. I don't, but I'm going to create the downstream. I'm going to call it ZZZ because, ZZ Top or who knows. And I'm just going to change it to Canal, make that the default. Otherwise, it defaults to Calico. So let me go and hit Canal. And boom. So we have the ability here to go ahead and either say what kind of node it is, what's on it. Now, obviously, this is the first node in the cluster, so we need all 3. If you were doing it as just like 3 management nodes, you would leave worker off or you would leave worker on. It's up to you. Because we're using self-signed certs, I've got it set to insecure. And I'm going to go ahead and copy that. And all I have to do is go back to our workshop and paste it in. Whoop, wrong keys. There we go. And it's going to spin up an agent that's going to start talking to the cluster. So we'll go ahead and run. Yeah, I was doing this earlier, where it's not going to give me a clean output. Okay. Now ps-cef grep contain. And we can see it's already spinning up container D. Okay, it's doing the install for us. And the nice thing about it is I don't have to go and set up all these repos and everything. It's going to pull everything through and build out from this script. Now, obviously, if you've got separation of duties, if you want to kind of separate these things out, we can also go into the clusters and do import existing. This is a great way to start managing other upstream Kubernetes providers, including Tanzu and OpenShift, okay, or generic, okay, kubeadm, kubespray. So you've got a lot of options here in terms of how things are deployed, how things are managed, okay? We're going to wait. It does take a minute or two for it to come up. You can see all the different containers coming up right now. Okay, what we're going to do is we're going to go to the next challenge and we're going to come back. We're going to go to the monitoring challenge because everybody loves a good monitoring challenge. Okay, now for the monitoring challenge, actually, that kind of flipped. Boop, perfect. Now we can see Kube API and stuff, and this is that one downstream node. Okay, so for the monitoring challenge, we're going to deploy a monitoring app. We're going to do it with the app catalog. Okay, so if we go back to Rancher, we have our local cluster and we have our ZZZ. Let's do it in the local because ZZZ is not ready. I'm going to go to apps, and I'm going to go ahead and click on monitoring. So again, this is using Prometheus and Grafana and deploying a ton of charts for you. And I'm going to make this super easy. I'm just going to install, next, install. Oh, hit install. There we go. 3 clicks. 3 clicks to deploy an entire monitoring stack with dashboards and everything like that. Okay, great. Well, we're going to let that run. Let's go back here and do a top. Yep, Calico's running. Kubelet, everything looks good there. So here's the cool part, right? Because this is using Helm in the back end, we can actually minimize this. We can close it. It'll still run in the back end. What we can do, let's go back to Cluster Manager and just take a look at the status of the ZZZ and the node. So we're just waiting for the node to finally check back in. I should say the Kubernetes, the cluster agent. So the first one spun everything up and the second one deployed Kubernetes. So it looks like it's going. Let me uncheck that. And we should start, it'll go live hopefully in a second or two. Okay, as far as monitoring, so the success, the Helm went and deployed. And again, while we're waiting for all the notes, we can let that run and just monitor it. But like I said, we could close that. Notice we now have our ZZZ. So the cool part about it is now we actually have a downstream cluster. We can start to manage it. We can manage it in a lot of different ways. Let's say we wanted to put Longhorn on it. So notice I'm on the ZZZ cluster at the top. You can see it. I'm in the app catalog. I can go ahead and click Longhorn, and I'm going to do 3-click install because it's so easy. And now I'm deploying Longhorn on that ZZZ downstream cluster. One thing to note about this app catalog, you can absolutely, let's go look at the main one, the local one. You can absolutely at any point in time create your own repository, and it's just Helm charts and another YAML for the icon and another YAML for some questions. But you can absolutely deploy this into air gap environments where you've got your own catalog of your own specific apps that are local to you. Very easy to do, very clean. Actually, much better than allowing people to click anything and install anything. But then again, you may want to. Okay, let's take a look at the downstream. It said Longhorn was installed. So again, ZZZ, downstream cluster, Longhorn. And let's look at the notes. So now, not only was it like one curl pipe bash to build a downstream cluster, it was 3 clicks to get Longhorn installed. And now we're proxying through that main front door down to the downstream, down to Longhorn. All through the same RBAC, all through the same single user interface. Pretty powerful. Okay, let's take a look at monitoring. I'm going to switch back to my local cluster. Monitoring, we've given that plenty of time to soak. And let's go ahead and open Grafana. And close that out. And now that we have Grafana open, you can see our dashboard. You can see how much CPU you've used, total, 24 core, 46 gigs of RAM. You can see the disk utilization. And to keep us honest, we can go here to the local, to our dashboard and Rancher. And again, 24 cores, 46 gigs of RAM. So that matches up nicely. Okay, perfect. We've deployed monitoring. We've played Longhorn, a few others through the app catalog. Okay, so basically we're done. If you have any questions, if you want to look around and poke, if you want to play, I think if you absolutely want to schedule a workshop with us, feel free to reach out to us at NatSec. You can reach out to me individually. You can comment on this. There's a lot of different ways to get a hold of me. I'll put my personal email in YouTube so you guys can email me there as well. I hope this helps. I hope this was a simple of enough workshop, and I hope to be able to provide it to you and your team anytime soon. Have a great holiday.